We're going to be designing an experiment to look for the annihilation spectrum resulting from dark matter collisions in space.
Ooh, dark matter. We better bring a flashlight. I was making a joke.
I'm the boss. I make the jokes.
Sorry, go ahead and make your joke.
This is not the time for joking. We're doing serious research which requires complete and utter focus.
All right, let's buckle down and work.
Hey, check that out. A video from Mr. Brust in college. Yes, we're still wondering if you ever found the solution to that equation. What we're going to do now is review a little bit of Chapter 3A. Remember, 3A is the first part of 3. It's basically just a bunch of equations with some application thrown in. We start very simple with one-step equations. 3A2 was two-step equations. Then we go to multi-step equations, and I showed you a couple different ways to solve those equations. And the last step is equations that have variables on both sides of the equation. All right, so what I've done is I've put here on this side some review questions that come from your textbook, and I'm just going to scroll down and look. These are all very typical questions. You could see lots of these types of equations on the test. Remember, you do have a review to do, so when you're looking at these types of equations and you're doing the review, try to do it all by yourself. Don't try to look at the answers like you might do a little more often on the homework. You wanna try the entire review, and then you check the answers and you see how you do. All right, so let's start. And we're gonna give ourselves some space here. Let's start going through some of the equations. I don't expect you to have very many problems with section 3.1, so I'll just do one problem from there. But if you remember, you just have to do the opposite, whatever the opposite is. And so I'm gonna pick number 8 here, which says y over, let me go through it, y over negative 3 equals 8. Alright, so you just have to use the opposite operation. So here, the opposite operation would be to multiply, because we have y divided by negative 3. So I'm going to multiply by negative 3, both sides. And if you remember, that cancels out. And we get y on the left equal to 24. And that's the end of that problem. But for section 3.1 and 3.2, you're going to be asked to check your solution. So if you remember the steps for checking, number 1, we're going to write the original equation. So y over negative 3 equals 8. That's the first step. The second step is to sub in your solution when you solve the equation. So we got y equals 24. So we'll sub in 24 for y. Divided by 3 equals 8. And then you simplify. So here we get negative 8 equals 8. Voila. Is that equal to each other? No, it is not. Did some of you catch this mistake we made over here? Check that out. Negative 3, positive 3. What's up with that? I did that on purpose to see if our check would hold up. Our check did not hold up. We got a negative 8 and a positive 8. So on your test, if this happens, you need to make sure that you go back to your original question and you double check all of your work, just as I did here. Oh, we forgot a negative. So that's going to change some things. So I'm going to redo the check. We're going to redo this problem. Wait, let's just redo the whole thing, way back to the beginning. All right, so we're going to multiply by negative 3. That's going to give us y equal to negative 24. Maybe some of you right now are just figuring out why we did the check. You're like, oh, I never knew that. This is why we're checking it. So the steps again to the check. You rewrite the original equation. You substitute your value in. So now we put in a negative 24 over negative 3 equals 8. And here we get 8 equals 8. That is the correct solution. So our check, let's label our check so the teacher knows exactly what's going on here. Here's our answer. Here's our check. We're all done with that problem. If you look at section 3.1, all of these, you just use the opposite operation. I mean, it's pretty simple. When it's addition, you subtract. When it's subtraction, you add. When it's division, you multiply. And when you multiply, you divide. So those are pretty simple. Let's go on to section 3.2. Ta-da! All right, so a good problem from section 3.2 is probably going to be number 13 here. So let's look at that. So 13 looks like x over 7 plus 3 equals negative 2. All right, so remember I taught you a little shortcut here. So pretend you're subbing in a value for x and you're going to evaluate this half of the equation. The first thing you do is you would divide by 7 and then you would add 3. So you write down the opposite of those. So the opposite of adding is subtracting. The opposite of dividing is multiplication. So this is the way that you built the equation, and this has to be the way that you take it apart. So the first thing you have to do is subtract 3. The next thing you do is you multiply by 7. So they tell you the steps. Now you just have to make sure that you follow equality properties, that when you subtract 3, you do it from each side of the equation. Draw a line. Remember the equal signs line up. So negative 2 minus 3 is negative 5. And on the left we get x over 7. Now it looks just like the problem we just did. If we multiply both sides by 7, what do we get here? Let's multiply there. Multiply. So the 7's cancel. We get x equals negative 35. And we're all done with that one. Now, the check for this works the same way. I'm going to skip it to save some time, but you write down the original equation. You plug in negative 35. Negative 35 over 7 is negative 5 plus 3. That equals negative 2. So that check will work out for us. That's section 3.2. You have look at all these different types of equations here. Let me pause this so I can find out what page that came from your book. Pause. If you look, this is on page 940. It's in the back of your book. This is called the extra practice. So if you didn't know this, each chapter has just a few problems that are called extra practice. So what I did is I took a picture of 3.1 to 3.4. We're not going to worry about the rest of it until the next chapter, but right now that's where I'm looking in your textbook. So if you're wondering what these equations are, maybe you can't see them too well on the screen, they're coming from your textbook on page 940. All right, so let's get back to the algebra. Okay, so on to section 3.3, and one of the questions that I really want to look at there is number 19. All right, if you notice 19, there's a distributive property involved in there, so let me write that out for us. 19. And for these longer problems, we're not requiring you to do the check, although if you have extra time, and you know you're going to have extra time, I would absolutely do that check so that you know that you're getting it right. You need at least a 70 on this test. All right, so we're looking at the whole equation, and we have to simplify here on the left. And whenever you can distribute, I recommend it. So right here, we're going to distribute. Now, Mr. Brust taught you that this number in front, that's not a positive 3, that's negative 3. So when you distribute, let's see what we get. 5x kind of hangs out. We get negative 3x plus 15. There's the key. Students are going to mess that one up. They're going to put minus. But it's a plus, and so now it's just combining like terms. We have 5x minus 3x, that's 2x, plus 15 equals 13. I'm going to subtract 15 from each side. They cancel out. We're going to get 2x equals negative 2. You divide both sides by 2, x will equal negative 1. Alright, so there's our answer for number 19. Let me plug it in and just check it mentally. 5 times negative 1 is negative 5, so I'm going to kind of write that down over here, minus 3 times negative 1 minus 5. Negative 1 minus 5 is negative 6. 3 times negative 6 is negative 18. Negative 18. This should equal 13. So remember, minus and negative, we plus positive. Negative 5 plus 18 is 13, so 13 equals 13. I said I wasn't going to do the check, but I ended up doing the check. I always did the check because you want to make sure you get these problems right, and the check is the easiest way to absolutely conclude that you're getting them right. Alright, so I'm going to do number 20 now because 20 looks a little different. It's still distributive property, but there's a little trick involved that I taught you. So we get 3/4 times 2y minus 8 equals 6. Remember the trick that I taught you? Yeah, the reciprocal. That's what I'm talking about. Reciprocals here. So I saw that fraction 3/4 in front. You multiply by the reciprocal, both sides. And what that does is it cancels that out. Ooh, that one I shouldn't have done. Do and undo. Undo that. All right, so now they cancel on the left, but on the right, nothing can't. Well, can't say nothing cancels. The 6 will cancel with the 3, leave a 2 and a 1. But this is going to be a very simple equation now. We get 2y minus 8 equals 8. All right, so we add 8 to both sides. Draw a line. 2y equals 16. Guess what y is going to equal? 8. Ta-da! We're all done with that one. So that's number 20 from 3.3. And the rest of them look very similar. As I look at them, just make sure when you combine like terms, I see here number 16, 12w minus 5 minus 3w. Make sure that you subtract that 3w. That's pretty straightforward though. Let's go on to section 3.4. All right, 3.4. Let me find a hard one here. Let's start with number 22. We get 10 minus 2x equals 3x minus 20. What I advised you to do was to look and find the variables. This one has variables on both sides. Pick the smaller one and then do the opposite. So the opposite of negative 2x is a positive 2x. And remember that minus and the negative, I'm going to use those words interchangeably. But you need to think of this as a negative 2x. What cancels the negative 2x? A positive 2x. So on both sides, we're going to add 2x. So on the left, read this like a book. When they get long, you should read it like a book, left to right. The 10 just comes down. Ta-da! These will cancel. See ya! Equal sign comes straight down underneath it. 3x and 2x is 5x, and the minus 20 comes down. Now this is a two-step equation. This is not difficult now. You can just add 20 to both sides. Ta-da! What do we got? Here we get a 30 equals 5x. Divide each side by 5. And guess what? 6 equals x. We're all done with that one. So that was 22. Let's do number 25. Well, no, let's go fraction. Let's do it up. Do it up with the fractions. Here we go. Number 26. This is about as difficult as it's going to get for you on this test. We get 3x minus 3 equals 3/4 times 2x plus 12. All right, so let's do the distributive property. That's one of my favorite properties. Ooh. Let's try that. Multiply through. This is different than reciprocal. You can do the reciprocal, but that gets a little bit tricky for this one because you'd have to multiply the left-hand side is a whole quantity. You got to multiply everything by the reciprocal. That can get a little bit messy. So let's just do the distributive property and see what we get here. 3x minus 3 on the left. We're not going to change that. When we multiply 3/4 times 2x, the 2 and the 4 will cancel. Let's just write it out first. 3/4 times 2x plus 3/4 times 12. Because that's what you do when you do the distributive property. It goes to both. So now I can do my canceling. Let me change the color here so we can see what's going on a little clearer. The 2 and the 4 will cancel and leave a 1 and a 2. And on the right, the 12 and the 4 will cancel, leaving a 3 up top and a 1 in the bottom. So let's simplify. 3x minus 3 equals, we get 3 times 1x, that's just 3x, over 2. So that can be written like this. That's the same as 3/2 x. If you didn't know that, we can just write 3 over 2x. That might come into play here in a few minutes. The next one, what do we get? 3 times 3, which is plus 9. All right, so 3 over 2, what does that equal to? That's equal to 1.5. That's 1.5. So I'm going to subtract 1.5 from each side right now. So minus 3/2 x. Remember, 3/2 is 1.5. So I know some of you right now are going, what? Why is it using that? We got to get comfortable with our fractions. 3 minus 3/2. How much is that? 3/2 is 1.5. What's 3 minus 1.5? That equals 1.5. Alright, so that's what we get there. Minus 3 equals 9. Let's keep going. Add 3 to both sides. Draw the line. They cancel. Let's give us some more room here. So we get 3/2 x equals 12. Now what? You can divide by 3/2, or you can multiply by the reciprocal. Let's do the reciprocal because I love reciprocals. I love reciprocals. Voila. Cancel, 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 cancel. So we get x equals How does this cancel? Let's cancel the 12 with the 3. That's going to leave us a 4. You're like, why does this guy, Mr. Kelly, cancel so much? Why is he canceling everything? Well, the reason why, well, you'll see in Algebra 2. I mean, it's going to come up. You're going to have these huge, monstrous functions, and you're going to want to make them as simple as possible, and the canceling's the way you do that. So I always cancel as much as I can, and it trains your brain to look for that canceling so you don't get huge numbers, which gives you more chance for making a mistake, a greater chance of making a mistake.
Sheldon,
What?
I need an aspirin.
Top desk drawer. Thank you. All right? Yes. Good.